Credibility theory. So let's do this faster question. Total claim amount per annum on a particular insurance policy follows a normal distribution with unknown mean theta and variance 200 square. Prior beliefs about theta are prescribed by normal distribution with mean 600 and variance 50 square. Claim amounts are observed over n years. State the posterior distribution of theta. Show that the mean of the posterior distribution of theta can be written in the form of credibility estimate. And now suppose that n equals to 5, total claim over 5 years are 3400, calculate the posterior probability that theta is greater than 600. So, question 1, we have the posterior distribution. So, part 1 first, just zoom in it thoda sa. So, we have the posterior distribution of theta is normal with variance given by sigma square is equal to 1 by n by 200 square plus 1 by 50 square close bracket, and mean is given by mu is equal to backslash sigma square nx bar divided by 200 square plus 600 divided by 50 square. Okay, so this came out, it has to be square. Okay, number 2, set z is equals to backslash of sigma square into n by 200 square. Then z is equals to n by 200 square divided by, so I'll just write this, I'll copy and I'll paste it instead of writing because I need to write the same thing. So this is there, come down, which is equals to n by n plus 16. Okay, and one minus z is equals to 1 by 50 square divided by this is equals to sigma square into 1 by 50 square. So backslash mu is equal to z x bar plus 1 minus z into 600. So mu can be written as a credibility estimate. Okay, third part was the probability we need to calculate. So backslash of sigma square is equals to 1 by, I have this already saved, every copied, so I don't have to write this every time. Just remember that you had copied so that you don't start even writing. Okay, this you had saved. So this is equals to 1 by, again I'll just paste and replace n only. So n now is 5. So therefore this is equal to 43.64 square. Okay, and alt equals to backslash mu is equal to backslash of sigma square control V n x bar Same thing, only here now it is 600, brackets close, is equals to 43.64 square, 3400 by 200 square, plus 600 by 500 square, 50 square, sorry, which is equal to 619.0476. Therefore, probability of theta greater than 600 is equals to probability of normal distribution of 619.0476, 43.64 square is greater than 600. Therefore, alt equals to probability of normal 0, 1 is equals to 600 minus 619.0476 divided by 43.64. Probability of normal 0, which is equal to probability n 0, 1 is greater than minus 0.436. Hence, this is equal to 0.6 into 0.67003 plus 0.4 into 0.66640, which is equals to 0.669. So hence this is the probability. Okay, coming down to next question. This is this question: let theta denote the proportion of insurance policies in a certain portfolio on which a claim is made. Prior beliefs about theta are described by a beta distribution with parameters alpha and beta. Underwriters are able to estimate the mean mu and variance sigma square of theta. Express alpha and beta in terms of mu and sigma. Okay, and then a random sample of n policies is taken and it is observed that claims are rising on D of them. Determine the posterior distribution of theta. Show that the mean of the posterior distribution can be written in the form of a credibility estimate, and show that the credibility factor increases as sigma increases, and comment on the result. This is a big question. Maybe this so much mathematical typing will not come in CS1 as they have said, but let's cover it. Doesn't matter if it comes also. Most probably it will come as an MCQ only, but we'll write. Okay. So first, backslash mu is equals to backslash alpha divided by backslash alpha plus backslash beta. Okay. So backslash beta is equals to dash alpha into 1 minus backslash mu divided by backslash mu. Okay. And sigma square is equal to backslash alpha backslash beta divided by alpha plus beta square alpha plus beta plus 1. Okay, so therefore this is equals to mu into okay, so this is there, and then equals to mu into 1 minus dash of mu divided by slash of alpha plus backslash of beta plus 1. So this is there. Substituting we have a sigma square is equals to backslash of mu into 1 minus backslash of mu, and in place of alpha plus beta we'll play backslash of alpha divided by backslash of mu plus 1. So backslash of sigma square is equals to backslash mu into 1 minus backslash mu divided by of alpha plus backslash of mu, and here it becomes mu square. Okay, so therefore beta is equal to backslash of mu square into 1 minus backslash of mu minus backslash of mu by slash sigma square into 1 minus backslash of mu divided by backslash of mu backslash of sigma square. Okay, so this is equals to, if you see everything is common, mu's have got cancelled. So again please do not write and just copy paste and make the necessary changes. So what I'll do is, since there's one mu needed, I'll give a space. So mu into 1 minus mu, here is mu sigma square. Here it will become sigma square into 1 minus mu, and from below also it will remove a sigma. So this is the value of my beta. Coming to part 2. So now here we have to find the posterior distribution f of theta given x prop to, remember we did prop to f of x given theta into f of theta. Next line, alt equals to backslash prop to backslash theta to the power d 1 minus backslash theta to the power n minus d backslash theta to the power backslash alpha minus 1 and 1 minus backslash of theta to the power beta minus 1. Again I'll not write, copying this, pasting and just adding to the power d plus backslash of alpha minus 1 and n minus d plus backslash of beta minus 1. Okay, and part B, posterior distribution, posterior mean. So alt equals to alpha plus d in brackets divided by backslash of alpha plus d plus backslash of beta plus n minus d is equals to backslash of alpha plus d divided by backslash alpha plus backslash of beta plus n. Backslash of alpha divided by backslash of alpha plus backslash of beta into backslash of alpha plus backslash of beta divided by backslash of alpha plus backslash beta plus n plus d by n into n by backslash of alpha plus backslash of beta plus n. Therefore it equals to, you can again copy and paste. I'm just writing everything. Most chances are these questions will come in MCQ, but for safe side, showing you all everything. Plus n. Okay, so credibility estimate, this is the form of a credibility estimate. Okay, and then next part 3, where we know z is equals to this. Z is equals to alpha plus zeta by n. Now this will decrease as alpha plus beta increases. Okay, and vice versa. So from part 1, alpha plus beta, it's the same thing. I'm not continuing writing, it's a continuous of the same above values which we had calculated, mu into 1 minus u by sigma square. So you can just take the values from there, and then as increases sigma square decreases and so on. Okay.